Question number 15. Unpolarized light is incident on two polarizers. The axis of polarizers of both the polarizers are initially parallel. Okay. Second polarizer is then rotated to 360 degrees as shown. Okay, fine. So which means what? You will get the same intensity once again. Okay, fine. Let us not bother about it. Which graph shows the variation of intensity with angle theta for the light leaving the second polarizer? What is he asking is that when you have a light of unpolarized light, okay, of intensity I here, okay, let us say I naught. When it comes to it, let us say here, what will happen? When it passes through the first polarizer, definitely it will be I naught by 2. Okay. And when it, now you have initially like this, now you are slowly rotating this. Okay. You initially keep it at 0. I did not start the timer. Okay. You keep it at 0, then 10 degree, 20 degree, 30 degree and so on. You keep on rotating from 0 degrees to 360 degrees. In this process, you want to find out how does the intensity vary, right? Definitely intensity will continue to vary. Now, how does it vary? We know if you have these two transmission axes to be parallel to each other, you get the same value I naught by 2 itself in the output. If the value of this is equal to something like this, let us say it is a theta degrees, theta equal to 10 degrees, then what can happen? You get this as a I naught by 2 cos squared 10. How do I know this? This is nothing but your Malus law, right? So if I do it for 20 degrees, what do I get? I get this as I naught by 2 into cos squared of 20. Now like this, I keep on varying from 0 degrees to 360 degrees. Okay, which means I come back to the same position. So that's what I do. That's what has been given here. Cos squared of 360. Now what has been asked? Okay, which graph shows the variation of intensity with angle theta for leaving the light leaving the second polarizer? So for all the angles, he has drawn these referral points and he wants to find out which of these graphs will obey this. This is the question over here. Now how do we do it? The first thing is that we know that the intensity becomes half. The maximum intensity that you can get here in the output is only I naught by 2. Now let us look. Anything related to I naught by 2? No, it's not given. Then, now second one, you have cos squared 360, cos squared 0, right? So that means the intensity I naught by 2 will vary between cos squared 0 to cos squared 360, initial and final values. Which means what? Cos squared 0, see, cos 0 is positive, cos 180, let us look at the values here. Cos 0 is plus 1, cos 180 is minus 1, and anything which goes between 180 to 270, okay, so you will have positive values and as well as negative values when it goes through one cycle, right? If you want to know the exact variation, let us draw the cos curve. Let us draw the cos curve. This is your cos curve. This is your cos theta curve. This is the way how it looks like, right? So let us draw the angles also to be specific. So this is your theta equal to 0. This should be a theta equal to 90. This should be at 180. This should be 270. And this should be 360. What does it tell you? It means between cos 0 to cos 90, the values of cos theta are always positive. And from cos 90 to cos 270, values of cos theta are negative. And from 270 to 360, values of cos theta are positive once again. Okay. Now, when I say cos squared 360, what will happen? All the negative values will get converted into positive values, which means this value, this whatever we have here on the positive side will be retained as such. Okay, so I will retain it like this only here, okay, until here, but this one will become positive, and the shape of the curve, what will happen to shape of the curve? Will get inverted like this. Will get inverted like this. Will get inverted like this, right? Because everything it becomes positive. So you just put a mirror here and you draw an image here like this. This is what I have drawn, and this again retains the same value. Okay, it retains the same value. Now, which of these curves illustrate the same thing? So, for example, A, what do we have here? You have only one peak here, and then it goes away here. So definitely this is not the right one. This is not the right one. Now let us look at the option B here. Option B here, you see, from here to here, you have one peak here, and then you have an upper peak, and then again a lower peak, then again a lower peak, and then finally it goes back to here. So this curve mimics or shows all the features what you have drawn over here. So B is the right answer. But if you want to verify the other things, see, definitely this is not the right answer, because you see this becomes negative. So this is not possible. Okay, in an MCQ, you can either solve an MCQ by looking at the right options like the way how I started, or maybe you can also look at something like deleting all those options which are not possible. So this is not possible. Why it is not possible? because it's a negative value over here. Okay, in one of these options, see, luckily here you have all the three options to be given as positive. But if suppose by luck, if suppose we are given one option like this, second option like this, third one is also having a negative intensity, you can outrightly you can say that is not possible. So this is not possible, and this is also not possible because the same type of features are not allowed. So therefore, this is also not possible. So B is the right answer. Okay, let us take up the next question.